Chapter 1, Section 1.5, Linear and Compound Inequalities. A linear inequality in one variable is any relationship of the form ax plus b on the left-hand side, 0 on the right-hand side, and an inequality symbol in between. So what are the inequality symbols? We have less than, greater than, less than or equal to, and greater than or equal to. So how do we go about solving linear inequalities? First step, remove parentheses. And how do we do that? By distributing. Step 2, combine like terms that are on the same side of the inequality sign, if there are any. Step 3, get the variable on one side and the numbers on the other side of the inequality sign. Step 4, divide if necessary to get the variable having a coefficient of 1. And always check your answers. Now we have this caution symbol. What does that mean? Well, this is the key takeaway for this section. So the key takeaway is when you multiply or divide by a negative, you're going to always flip the inequality. So when you multiply or divide by a negative number, you always flip the inequality. And that's the key takeaway for this section. So let's review interval notation. We have some set notation written below, and we want to write it in interval notation. So number 1 is read as a set of all x's. The line down means such that. So this is a set of all x's such that x has to be greater than 4. So this means all real numbers such that the real number has to be greater than 4. So what's greater than 4? Well, normally we would say 5, 6, but also 4.0001, 4.2. So not integers only are we looking for. So things that are greater than 4, we will start with 4 with our interval notation, and we'll go all the way to infinity. Now infinity we can never include, so we're always going to use the parentheses. But what about the 4? Do we include it? Do we not include it? So we're going to look at the inequality sign, and the inequality sign is a greater than sign. So whenever we have a less than symbol or a greater than symbol, we're going to use a parentheses to show that we do not get to include that starting or ending point. Since our inequality sign showed that it was strictly greater than 4, we cannot include the starting point of 4, so we'll use a parentheses. When we have less than or equal to or greater than or equal to, we get to include that starting or ending point, and we'll show that by using a bracket on that starting or ending number. So for example, number 2, we have the set of all a's such that a has to be less than or equal to -3. So what does that mean? It's a set of all real numbers such that the real number has to be less than or equal to -3. So what's less than -3? Well, -4, -5, -6, but also -3.001, -3.2. So we are going towards negative infinity. So with interval notation, we need to start with the smallest number, which is negative infinity. And we're going to go all the way to -3. And -3 will have a bracket because we do get to include it because of the less than or equal to on the inequality sign. So for example, let's go ahead and solve, graph, write the solution in set builder notation and in interval notation. Number 1, x plus 6 is greater than or equal to -1. So if we go through the steps, we need to remove parentheses, which we don't have any. We need to combine like terms that are on the same side if there were any, and they're not. We need to get variables on one side and numbers on the other side. So we're going to subtract 6 to the other side. So x is going to be greater than or equal to -7. So on the number line, 0 is in the middle, positives are to the right, negatives are to the left. We see that -7 will be to the left of 0. We want the numbers that are greater than -7. Well, what's greater than -7? -6, -5, but also -6.999. So anything to the right of -7. Because we have greater than or equal to, we get to include the -7. So we'll put a bracket on the -7, opening up to the way that we shaded. So now let's look at interval notation. Interval notation says go from left to right and show me what you shaded. So with interval notation, starting from left to right, nothing at negative infinity. We started at -7, so bracket -7, and we're going all the way to positive infinity. And positive infinity, we do not get to include, so we will use a parentheses on that. For set builder notation, we start with our set marks, so the set of all. we use the variable x, the set of all x's, draw your line down, which means such that x has to be greater than or equal to -7. So once we get to that solving part, that's what we get to put in our set builder notation. So I'm going to let you try number 2 on your own. So I would pause the video and cover up the answers and see if you can get to the correct answers. Number 2 says 5 plus 3a is less than -10. So pause the video and try that example. Number 3, -5t minus 6 is greater than or equal to 24. We'll follow the rules and the steps from the previous page. We need to add over the 6 to the other side. So -5t is greater than or equal to 30. Then what do we need to do? We need to get the variable having a coefficient of 1, so we need to get rid of the -5. So we'll divide by -5, and there is that key point. Whenever you divide by negative, what happens to the inequality? It flips. So t is less than or equal to -6. So the number line, again, 0 is in the middle, positives are to the right, negatives are to the left. -6 will be to the left of 0. We want all real numbers that are less than -6. Well, what's less than -6? -7, -8, and so forth. So we know we're going to be going to the left. With -6, we have less than or equal to, so we know we get to use a bracket. And again, open the bracket up to the way that you're shading on the number line. So for set builder notation, we have the set of all. We're using the letter T. Draw your line down, that means such that. And we're going to have T is less than or equal to -6. I'm abbreviating set builder notation with SBN. Interval notation, IN. Interval notation, we will go from left to right and show me what you shaded on the number line. So we are going toward -infinity, and we need to start with the smallest number with interval notation. So -infinity is the smallest, and we're going to go all the way to -6, and we get to use a bracket because of that less than or equal to sign. So number 4, we have 2/3 y plus 1/3 is less than -1/2 y. Many students are kind of wanting to always get rid of fractions, and we are allowed to do so because of the inequality sign. So the first thing we want to do is find a common denominator and multiply by it. So the LCD, what's the first number? 3, 3 and 2 can all go into a 6. So we're going to multiply the left side by 6/1 and the right side by 6/1, and that will get rid of our fractions. So when we multiply fractions, we multiply just straight across. So 6 times 2 is 12, and 1 times 3 is 3. So 12 divided by 3 is 4, so we get 4y. Plus 6 times 1 is 6, and 1 times 3 is 3. We get 6 divided by 3, which is 2. Is less than -1 times 6 is 6, and 2 times 1 is 2. So we end up with a -3y. So now we get variables on one side, numbers to the other. We can add over the 3y and then subtract over the 2. That's one way. Or we can subtract over the 4y and then divide. So it depends on how you would like to do it. I'm going to go ahead and subtract the 4y over to the right-hand side. So you end up with 2 is less than -7y. Because I took the variable to the right-hand side, I am going to divide by -7. And when I divide by negative, remember the key takeaway is you have to flip the inequality. So -2/7 now is going to be greater than y. So again, some students don't like to write the variable on the right-hand side, so we'll write it to the left. This says -2/7 is greater than y, so y is less than -2/7. I have not changed the answer. I've just written it in the form where the variable is on the left-hand side instead of on the right-hand side. So where's -2/7? You can grab a calculator and type that in. You'll see that it's in between 0 and -1. So -2/7 would be about there, in between 0 and -1. The numbers that are less than -2/7 will be to the left. So -3, -4, -5, going all the way to -infinity. So now we need to do interval notation and set builder notation. Set builder notation says the set of all, we use the variable y, draw your line down such that y is less than -2/7. And then for interval notation, again, we want to go from smallest number to largest number. So from -infinity off to the left, we are going that direction towards -2/7 with a parentheses. Why a parentheses? Because we are strictly less than. So then on the number line also, make sure you put a parentheses to show that we are not including that point. So for the last two problems, I'll start you off, but I did give you the answers already. Again, I would pause the video, try the problems, and then check your answers. But I will start you off on the first problem number 5. We have negative parentheses x plus 2, close the parentheses, minus 5x is less than or equal to 3x plus 7. First thing you want to do is get rid of parentheses by distributing your negative. So when you do so, negative 1 times x is negative x, negative 1 times 2 is negative 2. So negative x minus 2 minus 5x is less than or equal to 3x plus 7. And then combine your like terms and go from there. On number 6, we had that 1/7 parentheses 3x minus 28 is greater than negative 4/7 x plus 1/4. Just like we did the problem above, we'll go ahead and distribute to get rid of our fraction. We multiply numerator times numerator, denominator times denominator. 1 times 3x is 3x, 7 times 1 is 7. And then 1 times 28 is 28, and 7 times 1 is 7. Is greater than negative 4/7 x plus 1/4. There are multiple ways to continue for this problem. You could divide 28 over 7, or if you just want to find your LCD and multiply every term by it, you could do so. Between a 7, a 7, a 7, and a 4, the LCD would be a 28, because that's the first number 7 and 4 can both go into. So you could multiply the left side by 28 over 1, and that would get rid of your fractions on the left, and multiply the right side by 28 over 1, and that would also get rid of your fractions. So you could reduce 28 over 7 and then distribute, all kinds of different ways to continue. So pause the video, come back and see if you get the correct answers.